Hello, my name is Jeremy and welcome to my wood shop in progress. Wanted to do a video going over how I am doing the insulation in the walls of my building. So this is a steel building with steel panels on the outside, steel roof, and then it's a pole building, so it has just 6x6s for the main structure. And then I have 2x4 girts because it is a little bit of an older building. And I am in zone 7, so it gets pretty cold here in the wintertime. But also, it does get pretty humid in the summertime, so you have to balance having a high enough R value and also making sure you're not going to have an issue with moisture in the walls. So the materials that I chose to do the wall insulation, I have EPS foam 1.5 inch, and that just goes in between the 2x4 girts here, and that sits up against the steel siding. And then I have 5.5 inch rock wool, and that kind of goes the whole distance in between the structure. And then facing that, I have 2 layers of 7/16 inch OSB, and then on top of that, for fire code, I am putting a layer of 5/8 inch drywall. So one of the biggest things that I was considering when doing this structure was I wanted cost affordability. I didn't want to totally break the bank, as well as VOC. I wanted to make sure I wasn't, breathing anything too toxic. And then also making sure that I was going to have a wall structure that was going to hold up over time. This is a 30-year-old building, but I did want to make sure that whatever I did wouldn't harm the building and also would allow it to still breathe, and also make it so that when I heat it in the wintertime, because I am heating it, that it would not have issues with condensation or anything else. So with my material choice, what I wanted to make sure is that because the steel on the outside of the building is a vapor barrier, so it has a perm value of basically 0 for all intents and purposes, even though it does have holes. So because of that, you really want to make sure that you're not going to have a situation where you also put plastic or something else on the inside of the wall, because that would lead to having a double vapor barrier, which traps moisture in your walls, which is not a good thing. So breaking down how I chose my materials, so with the 1.5 inch EPS foam, that is vapor permeable, so it has a perm value of like 3 to 6 per inch, which is still a moisture barrier, but it allows vapor to go through the material itself. So being against the steel is going to have some condensation no matter what, and you want that to be able to flow out. And with this foam, moisture can still flow out. If there's any trapped in the wall, that moisture can come through to the inside of the wall and not get trapped. The issue you might run into putting foam here is you could use XPS, the pink stuff, or the expanded polystyrene, or extruded polystyrene. The issue with that is that has a much lower perm value, around like 1 or so. So you are going to be a bit more restricted from the moisture, but it still works. The one thing to avoid is you do not want to use the faced polyiso. So the faced polyiso insulation, that also has a built-in vapor barrier. So if you put that like on here, especially if you have the foil on the opposite side of the steel, that's going to have an area where you're going to have a lot of condensation because moisture cannot leave that area, which is not a good thing. For interior wall cladding, I decided to go with the combination of OSB and drywall. You can also use plywood or other materials too, but with me, I found Menards, they have a section called dunnage, at least at my store, and they'll sell their cover sheets or anything else, and I'll get full 4x8 sheets for like $7 a piece, which I think normally OSB is like $16 now or something, pretty crazy. So, and they even have like 5/8 and 3/4 sometimes, but that allows me to get 2 layers, 3/4 inch of OSB, which gives me a lot of shear strength, because you could also do a system where you screw on or you could even build a secondary interior wall, or screw on some pieces of wood to allow you to just put drywall right on here. But I wanted the extra screw holding power that you get by having that layer behind the drywall. So these 2 layers of OSB behind my drywall means that I can very easily screw anything all around. And also having these additional layers, I can also then have a little bit less airflow coming in through any wall penetrations like screws or anything else behind these walls. So talking about moisture, when you have a wall like this, it's going to have moisture coming from the outside, from the inside, and you're really trying to just balance that and make sure you're not trapping moisture inside of the wall or going to end up with condensation or issues inside of the building. So in this workshop, I am going to be running a dehumidifier and a humidifier just to make sure I have equilibrium, because I am doing woodworking in here, so I want to make sure my wood stays at the right humidity. But I also want my walls to breathe, and having that exterior steel, which is a vapor barrier, I wanted to make sure that I really could not put a normal plastic vapor barrier behind my OSB or drywall, because that would trap moisture inside of the wall cavity. So you could do a smart vapor barrier like Intello, Membrane, or Modrex, but that was a little bit outside of my budget, and also it kind of changed how I would install things. And realistically, when I added up all the values, the perm values for my foam, and I'm doing 2 layers of OSB and a layer of drywall with paint on it, and when I added all those things up, I was already going to have like a 0.6 to like a 1 perm full system rating. So I really didn't need to have anything additional in terms of interior vapor barrier, even to allow moisture to come through and keep moisture out, because I was going to be preventing that moisture anyways through the materials that I chose. So I chose mineral wool because it's very easy to put it inside of these bays. The way the structure works is you really can just stack it up and cut it to form, and then it really holds its shape very well. So once I put over the OSB on top of it, it really is going to be very simple to just screw the OSB on, and it just holds it all together. The issue is with these wider bays is if you go with like fiberglass, especially bats, or maybe something else, is that you might run into the problem of sagging it or making it a little bit harder to assemble the wall structure. But the mineral wool itself holds its form very well, so you really don't have to worry about that. You just kind of stack it up, cut it to size, put your paneling on, and you're done. But also having that fire resistance that you don't get with foam, and even fiberglass itself isn't too fire resistant in the worst cases. And being a wood shop, I did want to just make sure, being as wise as I could with materials, even though it is a bit more expensive. And then for the actual wall paneling itself, I can get 7/16 inch OSB very cheap. So I ended up doing 2 layers of that, where I'm going to do 2 layers of that, and a layer of drywall, because depending on your zoning, you really need at least 1 layer of drywall, or potentially 2 layers of drywall, fire rated, for a garage or a workshop with codes. And if you don't do that, you have a fire, your insurance might not cover you if you have just like wood wall paneling on the inside of your building. So a big question that I had to think about was spray foam. And there's 2 big reasons, or 3 in my mind, why in general I don't really love spray foam. And those reasons are cost. It does cost, I think for this whole, I had about 640-ish square feet of walls here that I was dealing with. And I was going to be around the $4,000 to $5,000 price range to get that spray foam, the closed cell spray foam, which isn't great. I think all in all, when I did all my layers here, I was in at about like $1,500 with my drywall, OSB, and all my wall materials, which isn't that bad of a price for the amount of coverage I'm doing. And then the spray foam was that much more. And then the other 2 issues with spray foam in my mind are your VOCs. So, a lot of the materials I'm using, like the OSB, the mineral wool, it's Green Guard certified, which basically means it has a lower amount of VOCs coming off. It's not 0, but it is less. And there are things that have come out with different types of closed cell spray foams, even open cell, that they do give off more off-gassing, and that's not really something I want to be breathing in my space. So that's another thing. And also the big thing for me is also fire resistance. When you do spray foam, you really need to have at least 1, if not 2 layers of drywall on it as a fire break. And then in the case of an actual fire in the structure, that foam does go up pretty fast, and even inside of a wall cavity, you might have an issue with, even with drywall on it, if it caught fire, you might lose a lot more compared to a material like blown-in cellulose or your mineral wool that has that fire-resistant properties that it really is not going to want to burn as much as foam will. I do know I do have some foam on the outside, but that is contained between a layer of mineral wool and the steel, so I'm a bit less concerned about that small layer of 1.5 compared to if it was a whole layer of 4 or 5 inches of spray foam. Another option I considered, and this was my first choice, was I wanted to do a combination of my same wall structure, so having that OSB and the drywall on the outside, but rather than do mineral wool, I was going to do blown-in insulation. But the issue I found with that is, in addition to the fact that before you install that, I would have to finish all of my paneling on the outside and then drill the holes in, which isn't a big deal. But you run into issues with potential settling. So over time, you could have some settling that will affect your R value. And in addition to that, I would still probably have to do foam because I was wary about putting that blown-in insulation right against the steel. Because again, that steel will have some condensation no matter what. And having that blown in right up against it, you run into the same problems of moisture getting inside that blown in and staying in there. Again, it will migrate out over time, but not something you really want to be dealing with. And when I looked at that whole thing that I was going to do, still do the foam, all the labor blown in, and I compared that to just doing the mineral wool insulation, well, I would have to blow in the insulation, might have problems, whereas the mineral wool, it just sits there and I'm done. You know, very low on the install. I mean, blown in, the big difference is it's cheaper, you know, so it would have been about a third the cost, if not a little bit cheaper, to do blown in for the same square footage as the mineral wool. But you do have a little more labor as well as doing with that blower, and then you have the issue with settling over time. But again, I think it's still definitely a good option, and in that same system I was going to do, I was going to also add that layer of either Intello or membrane just to have that vapor barrier. But again, once I broke out all of my different materials with their perm ratings, I really didn't need to have that additional moisture protection because my perm rating between the drywall and OSB, which themselves are class 2 or class 3 moisture barriers, you really don't need to have that additional protection on the inside because those are going to prevent a lot of the moisture from coming through, but still allow the structure to breathe. Another option I chose not to pursue was you can get 8-foot wide fiberglass, or there are combination materials that are designed for these pole buildings. But the issue is they're not too expensive, but either they come pre-attached with a vapor barrier, which again, you don't want to put a vapor barrier in the structure because that will prevent you from drying to the inside. And then also that stuff can sag over time, and that's a big thing I saw online was people reported that they had sagging insulation, which is going to lead to a space where you're not getting quite the same amount of insulation value. And you still would be facing it the same way with this material, your OSB and your drywall. So at the end of the day, it's not a huge deal. So that's how I'm doing my walls. I think all in all, I'm somewhere around like an R32 and R33, which is about the same number you get with spray foam, closed cell. But the biggest things to me are this system is going to allow moisture to flow out, so I'm not concerned about moisture being trapped in the walls and having issues with that. I'm still getting a lot of R value, and also in my actual wall structure, having that 2 layers of plywood behind that drywall allows me to screw things in very easily, and also allows me to do better air sealing because I'm having 3 layers of material on my walls, so that really allows me to have better air sealing, which is one of the more important things than even R value, because if air is penetrating your structure, it is starting to eliminate a lot of your R value entirely. So I hope you found this video informative. If you have any questions, let me know in the comments. I'll be more than happy to answer them. I know that as I did this project, I went back and forth from spray foam to blown in to my current situation that I finally decided on. So more than happy to answer any other questions you have. Thank you all. I'll see you in the next one.